All right, so we're going to look at inequalities, review of inequalities today. And this should all be review. I know you guys have done this stuff before, but we'll run through it. So let's talk about graphing inequalities. If we are graphing inequalities that have an equal sign attached to them, do we use a closed or an open dot? Which one? Closed. Now, I'm going to show you a trick for remembering that too. And so then the other inequalities, the ones that do not use an equal sign, use an open dot, open endpoint, okay, when we're graphing these things. So one way that we will look at solution sets to inequalities is we're just going to, in the solution, we're going to use inequalities. We'll call that inequality notation. For example, the solution might be something like x is greater than 3, okay? The other way that does the exact same job in a slightly different way of expressing solution sets is what's called interval notation. Now, interval notation is raise your hand. Have you guys seen interval notation before? You haven't seen that? Maybe you called it something different. Interval notation uses parentheses or brackets, comma, and infinity symbols to do the same job. Parentheses indicate not included or open intervals. So parentheses go with this row. Okay, open endpoints, inequalities with no equal signs, and brackets correspond to closed endpoints or inequalities with equal signs. Okay, so let's just try an example. Like, what if we wanted to graph the inequality x is greater than or equal to 8? How would I do that? I'm just going to call that 8 in the middle on the number line. What am I going to do? What do you think, Mackenzie? How am I going to graph that? X is greater than or equal to 8. Closed dot, okay, at 8. And which way am I going to go? To the right. Very good. Okay, give me thumbs on that. Does that all make sense? You guys are good with that? Okay. How would I write that using interval notation? Okay, so here's the trick with interval notation. To start off, sometimes it's easier just to start with the comma in the middle. And what the comma does is it separates the left and right endpoints of the interval. It's really easy to go from a graph to interval notation. And so if you're trying to convert from inequalities to interval notation, if you want to, you can always just crank out a real quick little graph which guides the process of writing it in interval notation. Say it that way. So look at that blue interval that we just wrote. What's the left endpoint of that interval? If an ant were walking on that blue interval, what's the furthest left he could go? 8. Everybody agree? So 8 is the left endpoint, so that goes to the left of the comma. Now this one's a little tricky. What's the right endpoint? And that arrow goes forever, right? So what's the right endpoint? Infinity, okay? It's kind of can you ever get to infinity? No, you can't, right? So infinity's not a number, but it's a concept. The idea that this arrow goes forever means that there is no endpoint, or you could say the endpoint is all the way out at infinity, even though you can never get there. So we put our infinity symbol, just a sideways 8. And now what do we put for symbols? What kind of a symbol goes with the 8 if that's a closed endpoint at 8? Bracket or parentheses? Bracket. There you go. So we get a bracket by the 8. Now, what do you suppose has to go with infinity, being as you never get there? Parenthesis or a bracket? Parenthesis, because you can never include infinity. You could never have a closed end point at infinity because you can never get there. So infinity always goes with a parenthesis. Okay, and parenthesis is just singular. Parentheses is plural. Just put that out there too. Questions? Give me thumbs on that one. Okay. All right, we'll get some more practice. How about this one? What if we're graphing A is less than -1. So I'll put -1 in the middle. Let's graph that guy. What do you think? So what kind of endpoint, open or closed? Open, good. Okay, open, because I'm not including an equal sign, right? Am I going left or right? Left, very good. Okay. So there's my graph. Now let's turn this into interval notation. So we'll start with our comma. What's my left endpoint this time? Say it again. Okay, but positive infinity or negative infinity? Because they're very different. Negative infinity. If I'm going all the way out on the number line to the left, that's negative infinity. That's positive infinity. Right. So on the left, we've got negative infinity with parenthesis or bracket. Parenthesis. What's my right endpoint? -1 with parenthesis. There you go. Okay, good. So there's an easy way to remember this. This is kind of my little trick for remembering this stuff. All the stuff in blue requires more ink to draw than the stuff in red, and it all goes together, right? It takes more ink to draw an equal sign with an inequality. It takes more ink to fill in the dot than to just have an open dot. And it takes more ink to draw brackets than it does parentheses. So it's an easy way to kind of think about how all those things go together. All right, solving inequalities. So that's what we're gonna start working on, is solving inequalities. It's exactly the same as solving equations with one exception. You tell me, if I multiply or divide both sides of an inequality by a negative number, what do I have to do that's different than equation? One extra rule. Good, I've got to flip the inequality, don't I? Yep. Got to reverse the direction of the inequality. Okay, so let's try an example. How about something like this? If I want to solve this inequality, I'm going to deal with this the same way I normally would, right? I can't point to a single x yet, so I can't isolate it. I have to do some simplifying. What would I do first here, Miranda? What do you think? Okay, good. So inside, I can't really do anything. But what would I do next if I've got to simplify this? I'm going to end up having to combine some like terms. Distribute. Sure, I got to distribute that -3, don't I? If I distribute that -3, I'm going to get my 21x. What's that going to give me? Minus 15x. Good. -3 times +9 would be. Okay, good. So minus 27. Does that make sense? Is greater than or equal to 7. Let's combine like terms. Everybody, what's 21x minus 15x? 6x. So I've got 6x minus 27 is greater than or equal to 7. Ben, what are my last two steps in order to get that x by itself? Add by what now? Add by 27. There you go. So add 27. 6x is greater than or equal to 34. You said divide by 6. I like that. So that's going to give me the solution. X is greater than or equal to, let's see, that would reduce to what, 17/3 if I divide top and bottom by 3? So I want to graph this thing and put it in interval notation now. Okay, now we don't want to write, like there's a temptation sometimes to write these as mixed numbers. That's middle school stuff. We don't do that anymore. But we want to think of that as a mixed number, even though we don't want to write our answer that way. What would 17/3 be as a mixed number? How'd you get that? That's right. Yeah. Okay, right. So 3 goes into 17 5 times with how many remaining? 2 remaining over the 3. So 5 2/3. That gives us a little bit of a hint where to put the endpoint then. So if that's 5, I'm going to go out to 5 2/3, put an open or closed endpoint, everybody. Closed because I've got an equal sign, right? Takes more ink to draw the equal sign, more ink to draw the endpoint because I got to fill it in. And I'm shading in which direction? To the right. Okay, so what's that going to look like then? Keep in mind that's 17/3. What's that going to be in interval notation then? Let's see. To essay, what's that going to be in interval notation? There you go, bracket 17/3, comma, infinity parenthesis. Excellent. Okay, good. Okay. All right, let's tell you what, I think we're okay with those. We'll come back if we need to. Let's look at this one. Okay. So I've got to do a little simplifying. What do you think, Melanie? What do I have to do here to simplify that? Distribute. Okay, good. So if we distribute the 4, we distribute that 4. Everybody agree that's going to give me 48x plus 16 on the left. And on the right, if I distribute the 16, I get 48x minus 160. Okay, what's next? Arson, what's next? What am I going to do, you think? Okay, so what would I do then? So I'm subtracting what from both sides? 48x. Okay, so let's do that. If we subtract 48x, oh, that just cancels both of those, doesn't it? Right, and so I end up with 16 is greater than negative 160. Trenton, how do you interpret that? What do you think? 16 is greater than negative 160. So it is true, right? Okay, so if it is true, what's the solution to this inequality then? Not sure? Anybody want to hazard a guess on that? Okay, or then you got an idea? What do we do with equations if the variables went away and we got a true statement? What did that mean? If the variables disappear, it means it must not even, the variable must not even matter. It's all real numbers. Exactly. It's all real numbers. If it's a true statement, whether it's an inequality or an equation, it means all real numbers are in the solution. And remember, we call that an identity, right? Okay, give me 1 to 5. Does that make sense? Is that ringing a bell from a couple sections ago? Okay, good. Okay, let's try this guy. Same kind of thing. Well, would you guys all agree I've got to simplify this? So what do I distribute on the right side here? The negative, right? Which is really -1, isn't it? I'm going to distribute the negative, and let's see what happens. So I get on the left, 6x minus 4 is less than or equal to. On the right, I get 3x minus 12. And subtracting a negative is adding, right? Everybody see that? If I distribute the negative to the negative 3x, I get a plus 3x. So if I combine like terms, 3x plus 3x is 6x. So I get 6x minus 4 is less than or equal to 6x minus 12. Well, just like before, look, the 6x's cancel. So the x's go away. And this time I get -4 is less than or equal to -12. Thaden, how do you interpret that? First of all, true or false? False. So how do you interpret that? Okay, which means what's the solution? Then what values of x work? None. No solution. Good. Okay. False. No solution. So we'd call that an inconsistent inequality. There's no solution. Okay. And then all these other ones we did earlier, like this was an example of a dependent inequality. How come? Because it works, but it depends on the value of x. As long as x is greater than or equal to 17/3, it's true. So it depends. There are some values of x somewhere it doesn't. Whoops. Okay, good. Okay, so now let's move up to compound inequalities. So compound just means two or more things taken together, right? So what's a compound inequality? Well, it's going to be two inequalities taken or joined together. So there's two different flavors of compound inequalities. There are or inequalities and inequalities, and they look different. An or inequality, let me ask you something. Um, Raise your hand, and listen carefully here. Raise your hand if you are taller than 5'8" or shorter than, let's do this. If you're taller than 5'6" or shorter than 5'10". Raise your hand. Raise your hand if you're taller than 5'6" or shorter than 5'10". Okay, everybody in the world would raise their hand, wouldn't they? Everybody agree with that? Because everybody is either taller than 5'6" or shorter than 5'10", right? That describes every single person in the world. The point is, for an or statement to be true, how many parts of the statement have to be true? One of them or both of them? Only one of them for an or statement. As long as one of them is true, the whole statement is true, okay? So think about this then. If an ant were walking along this shaded region, the ant can't be in both places at the same time. The ant either has to be in the left region or the right region, correct? Everybody agree? Okay, so how would we write that then? We'd write that either as x is less than or equal to 4. So that looks to be this region over here, right? There's the x is less than or equal to 4. Or, and by the way, this is the symbol for or. Okay, let's write that down. Oops. That's what that kind of that capital looking V is the symbol for or. Or the other part of it is x is greater than 1. So x is greater than 1 is the red part. And it would make sense for us to use the word or there because you can only be in one of those two places at the same time. Both of those statements can't be true at the same time. Okay? Give me thumbs on that. Does that make sense? So one way to think about that is an or statement always looks like if I'm rowing a canoe towards you, the oars would stick out to the side, right? So it looks like the oars on a boat that's coming towards you. That's what a graph of an or statement looks like. In interval notation, what would that look like? Well, there's how many intervals do you see up there? 2. I see a blue interval and a red interval, don't I? There's 2, and I know there are 2 because I have to pick my pen off the board to create the second one. Anytime I can put my pen down and not pick it up, it means I'm drawing a single interval. But if I have to pick my pen up, it means I'm drawing more than one interval, right? So how would I say the blue interval? Okay, parentheses, negative infinity, comma, bracket. Everybody agree? Okay. How would I say the red? Comma, infinity, parentheses. Okay. But how do I say or? Now notice that or changes. This is kind of weird in math. When we're using inequality notation, notation means the way you write something in math, right? There are different types of notation we use. Well, if we're going to write the answer using inequalities, we call that inequality notation. And I'm going to make a note of that. I think that would be useful. Oh boy. So there's inequality notation. When we use inequality notation, or is written as a V. When we use interval notation, or is written as kind of like a U, stands for union. There's an easy way to remember that. If I tip that V sideways, doesn't it look like an inequality? It's sharp like an inequality. So there, that's how you remember. V's go with inequalities. If I tip that U sideways, doesn't it look like parentheses? Right? So U goes with interval notation, which uses parentheses. Okay? But they both mean or. All right, sometimes when we're using interval notation, like in my AP calculus class, a lot of times, we'll take a shortcut. And instead of a U in the middle, we'll just put a comma, which really a lot of times we do. I prefer that, but on the assignments, it's going to expect you to use that union operator, that U in interval notation. Okay? Give me thumbs. We good? All right, so solving inequalities in two variables. We'll skip this one. We only need one example with you guys. So if we're doing an or inequality, or inequalities always occur in two separate intervals, and what do? We just solve them individually. It's no big deal. We just like put a line down the middle and do them one at a time. Okay, so how about this left one over here? Let's do that one first. What's my first step to isolate the x? I'm going to scoot that over just a little bit, I think. Yeah, let's do that. There we go. Okay. What am I going to do first? Multiply by -3, exactly. Get rid of that. Yeah, I'm going to multiply the whole thing by -3/1 on both sides, right? In fact, I'll just do this. Okay. So what's that going to do on the left side? It's going to cancel the -3 on the bottom, isn't it? That's the whole point. We're undoing dividing by -3. So we just get 8 minus x. -3 times -5 on the right side gives us 15. Okay, what do I have to remember to do? Got to flip the inequality. Good, because I'm multiplying by a negative. It means I've got to flip that inequality around. Okay, Abby, what's next? Get that x by itself. Subtract 8. Excellent. Subtract 8. Okay, so that's going to give me -x is greater than or equal to 7. Last step. Melanie, what's my last step to get that x by itself? I got to get it. Right now it's not an x, it's a -x. How do I undo that -1 being multiplied by the x? Divide by -1. So I could, now the nice thing about dividing by -1 is it's the same as multiplying by -1. Either one doesn't make any difference. I prefer to think about that as multiplying both sides by -1. It just seems easier, but you can divide. It's fine. Either way, Johnny, what am I going to get if I multiply or divide both sides by -1? Okay, I'm going to get x and -7. And what do I have to remember to do? Flip the inequality. Because I multiplied by a negative, I've got to flip that. And so I go back to x is less than or equal to -7. I bet you guys would all tell me right away that that's going to amount to a solid endpoint at -7 shading to the left. Agreed? So there's half of the solution. There's the solution to the first part of that or inequality. Now let's do the second one. Miranda, what am I going to do? I got to isolate that x. First step. I could. That's fine. I could clear the fractions. Yeah, we can do that. Let's do that. So if we multiply by 2, the entire thing, that's fine. If we multiply by 2 and I distribute that, I'm going to get a 10 minus, right? I got my 10 minus 3x, because it's going to cancel the 2, right? I'm going to get 6/2, is less than -2. Good. Okay, now what, Miranda? Good job. Cleared the fractions. I like it. Okay, I could. I could add 3x. That's fine. I could add 3x to the other side and make it positive. That's fine. That's a possibility. So we got all these alternate approaches here. I like it. The other thing we could do, if we want to leave the x there, if you're unsure, write down order of operations and just go backwards, inverse operations. So what if I just kept the 3x there? Subtract 10. There you go. Okay. Either one would have been absolutely fine. So if I subtract 10, those guys go away. I get negative 3x is less than negative 12. Last step, divide by negative 3. And that's going to cancel the negative 3's. And I end up with x is greater than. Good, I got to flip it, don't I? Because I'm dividing by a negative. Greater than 4, right? So doesn't that amount to an open endpoint at 4 shading to the right? Okay, and look at that. My solution looks like an OR solution, doesn't it? Okay. And so what would I have to put in the middle then? Okay, in the middle, if I want to write out this solution using inequality notation, how do I say OR with inequalities? With a V. Good. So, whoops. So there is, oops, I wanted to make that. There we go. So there's my solution written as an inequality using inequality notation. Now let's turn that into interval notation. What's the blue interval? Parentheses, negative infinity, comma, negative 7, brackets. How do I say OR? U. And then the red interval. Okay, parentheses 4, comma, infinity. Good job. Okay, we're getting this, right? Okay. Give me 1 to 5. How are we doing? Is this pretty much review? Remember, guys, remember doing this last year? Maybe not quite this involved, but I'm sure you remember doing this. Okay, so the other type is an and inequality. Okay, how would I say something like this? Well, the way we'd say that is when we have an and inequality, notice it's only a single interval. I can put my pen down and graph the whole thing. So this is written as a 3-part inequality with the x starting in the middle. Now, this is how I say this. A lot of times people want to read this like a sentence. Negative 2 is less than or equal to x, and x is less than 5. No, you start in the middle when you have a 3-part and inequality. You start with the x and you say x is greater than or equal to negative 2 and less than 5. So you're bracketing it or pinching it between the bottom value and the top value, which describes that interval, doesn't it? So in this case, we've got this solid blue endpoint on the, oops, blue, not red. Got the solid blue endpoint on the left. We've got this open red endpoint on the right. And then x is all the values in between those, right? See how that works? Okay. Using interval notation, it's super simple. Using interval notation, it's only a single interval. Well, it's got a negative 2 on the left, a 5 on the right. We put a bracket with the negative 2 because it's closed and a parenthesis with the 5, just like you'd expect. Okay. So with and inequalities, you can technically write these using an and symbol. So we could say x is greater than or equal to negative 2 and x is less than 5. Technically, that's okay, but it's much, much better to write it as a 3-part and inequality. Less confusing, too, because when you write a 3-part and inequality, it looks just like the graph, doesn't it? The x goes in the middle. The lower limit, the lower boundary goes on the left, the upper boundary goes on the right. And notice how the inequality signs always open to the right, just like a number line does. The numbers get bigger to the right as we move along a number line. Okay? So let's try a quick example or two. So what about this one? Now this is written using the word and, which is not the best way to do it. But if it's written that way, we'll just treat it as 2 separate inequalities that we'll solve separately. So if I solve the blue one, you guys would all tell me the 2 steps to isolate x are subtract 3 and divide by 2, right? Everybody agree? Do a little mental math. What am I going to end up with if I do those things? X is greater than negative 6. Give me thumbs. Everybody agree? Okay? And there's my and symbol. How about the red side? What if I add 2 and divide by 8 to isolate the x? X is less than 4. Okay. So x is greater than -6 and less than 4. Can you think of a better way to write that? Instead of as 2 inequalities, can I write that as 1 inequality? Johnny, you have an idea? If I put x in the middle, what would I do? X is, okay, so I'm going to have less than 4 on the right and greater than -6 on the left, right? So, and we'd start in the middle typically. Typically, we'd start in the middle and then work from left to right. So x is greater than -6 and less than 4, but much better way to write it, isn't it? If I were going to use interval notation, what's that? Describe that, Miranda. What's that interval notation look like? Or, sorry, the graph first. Open or closed? Open, good. Okay, and well, x is greater than -6 and less than 4. So I got open at -6. Open, what's my right endpoint? You're right, I am going to the right from there. You're absolutely right. I'm going to the right, but where am I stopping? At 4. Okay, so I've got an open endpoint at 4, and I'm just graphing everything in between, right? Now, I can only graph the parts in between because this is an and statement. Both have to be true at the same time. The only place where both of those are true at the same time is that purple region, right? Okay, give me thumbs. Okay, all right. And using interval notation, wouldn't that just look like parentheses, -6, comma, 4 parentheses? Everybody agree? Okay. Okay, how about this guy? What am I going to do there to solve for x? Okay, I got to multiply everything by -2, don't I? So there's first step. That's going to, now I'm going to do that to, what's crazy about this and what's really nice, if I've got an and inequality that's a combined 3-part inequality, I just get to do all 3 parts at the same time. I'm going to multiply everything by -2, distribute that to all 3 parts. So what's that give us? On the left, I get +10. Everybody agree? In the middle, it's going to cancel that -2, isn't it? Right? So in the middle, I'm going to get 12 minus x, and on the right, I'm going to get 4. Okay, what do I have to do to the inequalities? I got to flip them because I multiplied by a negative, right? So that's going to get flipped, and that's going to get flipped. Okay, Arson, what's next to get that x by itself? Subtract 12. Okay. Good, so those guys go away. Good, we get to cancel something in the x part, don't we? 10 minus 12 is -2. The 12s cancel, so I get a negative x, and 4 minus 12 is -8. Okay, last step. Divide by -1 or multiply by -1. Either way. This time, how about if we divide everything by -1? And what's that going to give us? We'll write our answer up here. On the far left, we're going to get 2. In the middle, we're going to get +x. On the right, we're going to get +8. And what do we have to do? We got to flip everything because we divided by a negative. So we get that. Whoops, we get that, don't we? Everybody agree? So let's see, Mackenzie, what's that graph going to look like? Closed dot at 2, okay, closed endpoint. Open at 8. And everything in between, right? Good job. Interval notation, Maylin, what's that going to look like? The bracket, good. Bracket 2, comma. But remember, with interval notation, there's no x's. We just put a comma. It's only numbers, parentheses, brackets, infinities. 8, there you go, with parentheses. Good. Okay, what about this guy? This is really a simple one. There's only one thing to do, which is divide by -2. Everybody agree? Okay, if I divide the whole thing by -2, what's that give me? I'm going to get 2, I'm going to get x, and I'm going to get -4, and I'm going to have to flip the inequalities, aren't I? Okay, now the whole point of this one is that that's not an okay way to write the answer because it's backwards. When we have an and inequality, we always want the inequalities to open to the right. So we get the x in the middle, the bottom number on the left, and the top number on the right. So what do I have to do to this whole thing then? I've got to take this whole thing and I've got to kind of flip the whole thing around, don't I? Everybody get that? So what are we going to end up with? I've still got my x in the middle. What's going to be on the left now? Okay, how am I going to write that? X is greater than, is it equal to or greater than? Just greater than, because look, what this says is x is greater than -4. So here's this part of the inequality, this part corresponds to that part, right? Everybody agree? What's the other side going to look like? And less than or equal to 2, which is that part of the inequality, which still stays the same. Everybody get that? Okay. All right, man, we are moving. This is good. So you're going to get some work time here. Next, what I'll probably do is, well, we'll work it out. I'll give you some time to work and get questions answered on this too. I want to look at 2 last examples. Okay, this is an and statement. If we solve this, it's pretty simple to solve, right? Just subtract 5 and divide by 2. Everybody agree? What's that going to give me if I do that? X is greater than 6. I'm going to get, no, not 6. Oh, you're right, 6. I subtract 5. No, what's it supposed to be? 7, because I'm going to subtract 5 and get 14. Divided by 2, 7. Everybody agree? Okay, and how about over here? I'm going to add 6. So I'm going to get 24, and then divide by 4 and get what? X is greater than 6. Okay, what's the answer to that? X is greater than 7 and X is greater than 6. How many of those statements have to be true for an and statement to be true? How many parts? Both do. So what's the solution set? What are the values of X that are both greater than 7 and greater than 6? X is greater than 7. Yeah. Now I'll show you how we can see that. Very good. If we look at a number line, there's 6 and there's 7, right? Okay, well, let's look. If we graph X is greater than 7, doesn't that look like that? If we graph X is greater than 6, doesn't it look like that? Well, in order for both parts to be true, they have to overlap, don't they? Right? So if this is an and statement, the solution can only be the part where they overlap, right? So the solution is X is greater than 7. Okay, now compare that to this guy. Okay, if we do this is an or statement, right? 4x plus 6 is greater than 34. If I subtract 6, I get 28. That simplifies to x is less than or equal to 7, right? Or what about this side over here? If I add 6, I get 12 divided by 3 is 4. How about that? Where is that true? Where is x less than or equal to 7 or x is greater than or equal to 4? If I graph this thing, I've got numbers at 4 and 7. Here's the blue solution, right, if I graph it. Here's the red solution if I graph it. So for an OR statement to be true, how many of them have to be true at the same time? For an OR statement to both have to be true, or only one of them have to be true? Only one of them has to be true. So what's the region where at least one of those is true? Both of them are true there. Yeah, or in between. But now they can both be true. That's fine. If they're both true, then at least one is true. But what's the answer to this one? Well, everywhere is a solution, isn't it? Every place is at least red or blue, isn't it? Right? So it'd be the whole darn thing. Okay? All right, good job. Man, we covered a lot today. That's more than normal for one day.